of schedule here, and I would like to jump ahead if we can. We've got the astronaut office scheduled at 12:30. Steve, I understand, is here. Am I right about that? There you are. Okay. We can hardly see out there. Steve, if you wouldn't mind coming up now and making your presentation, and then we'll proceed after lunch. So this is Steve Lindsey, of course, representing the astronaut office. Steve?
Thank you very much, and thank you for the opportunity to get a chance to talk to your committee today. You have a lot of big decisions to make and options to look at. What I wanted to do today, just for a few minutes, to kind of give you the astronaut office perspective of how we think about these things. We're obviously primarily an operational organization. We go execute the missions, we fly the missions, but we also work with all of the programs. So we've been heavily involved with every next program we've gone off to develop, certainly since the inception, shuttle, space station. When I came into the office in 1995, we only really had one program operating, and that was Space Shuttle, and we were starting to develop station. Since that time, fast forward to now, we're now supporting 3 major programs at the same time and flying on 2 of them. So we're quite busy, but what I wanted to offer was kind of an astronaut office perspective on how we're viewing where we're headed and what we think we should do. And the way we did this is I did a series of town hall meetings with the office, trying to get an office consensus, if you will, on what our office believes, what our position is on all of the activities that are occurring. For those of you that have been in the astronaut office, and there's a lot out here, everybody knows how impossible it is to get a consensus out of our office, but this is our best shot at it. So I want to talk kind of in general terms of philosophically what we think about where we should go, what we should do, and just provide that kind of as food for thought for you. I want to start with the next system, and I know we're all talking about a capability beyond low Earth orbit, but we strongly believe as an office that the next system we build, or the architecture that we put into place, needs to have capability beyond low Earth orbit. We believe a low Earth orbit only system is a dead end for our program. I think Mike mentioned that earlier, and we heartily concur with that. We think a LEO system would end when the ISS does, and we think we need to go after an architecture, or whatever we decide here, something that goes beyond low Earth orbit to other destinations. Speaking of the next architecture, we believe the next architecture should be able to accommodate several potential destinations. There's a lot of ideas out there whether we should go to the moon or go to an asteroid or Lagrangian point. We think the architecture should be able to support all of those types of places. We believe that the building blocks of this architecture will probably be in place for at least the next 30 plus years, maybe longer than that. And along those lines, the heavy lift that we all know that we have to build to go beyond low Earth orbit needs to be heavy enough. And when I say heavy enough, that means both in mass, in terms of the lifting capability, but also the volume in terms of shroud sizes and things like that, to be able to have a reasonable chance of going to more distant destinations such as Mars with a few launches as opposed to many, many launches. We're learning now as we struggle with the upmass challenges for the space station program in the shuttle, for example, is that oftentimes we are constrained by mass to space station, and oftentimes we are constrained by volume to space station. Sometimes we have the mass but not the volume, and sometimes vice versa. So whatever architecture we choose needs to be able to support both the mass and the volume to do the missions we want to go do. We also believe as an office that we can't afford, nor should we anticipate support to develop another heavy lift capability for many, many years if we elect to accept a stopgap measure today that doesn't accommodate several potential destinations. Next slide, please. And I just want to talk a little bit now about the next system. To give you a little bit of history, after Columbia, our office met a lot, and we worked with the CABE and a lot of other folks, but we also sat down as an office. We wrote a couple of white papers back in the 2003-2004 timeframe, one dealing with the OSP and dealing with, for example, whether we wanted to put retrofit crew escape into the shuttle and some questions like that. There's a couple of quotes I put on these charts for you that kind of refers to what our position was at the time. The first one being that we strongly recommend that NASA change the OSP Level 1 program requirements to mandate an order of magnitude improvement over the shuttle and crew survivability. The second quote from a second white paper, we believe an order of magnitude reduction in the risk of loss of human life during ascent compared to the space shuttle is both achievable with current technology and consistent with NASA's focus on steadily improving rocket reliability, and therefore should represent a minimum safety benchmark. As we work the Constellation program over the last 5 years, these are kind of what we've been looking at, and this is what we've been trying to design that system to do. The bottom statement probably says it best for us, and I'll explain that a little bit. What we believe is the acceptance of risks that we take should be commensurate with our level of experience. And what I mean by that is that we've been flying in and out of low Earth orbit for about almost 50 years now, and we have a lot of experience with that. So we think it's very reasonable that the next system should have a significant improvement over the previous system. From a national standpoint and a public standpoint, when we had the Columbia accident, we almost lost the shuttle program for good. I have no doubt that if we were to lose another shuttle, the program would end. And I wonder about the tolerance of the public in the nation and our government for another accident and ascent entry, given how long we've been doing it. So we know that in the future we're going to take a lot of risk. We know in the present we're going to take a lot of risk. We know even with an order of magnitude improvement, we're still going to take a lot of risk. But we think our risk should be commensurate with our level of experience. We're willing to take those risks. We accept that as our job, and we're proud to do that job. But in the exploration avenue and in lunar or Mars return, things like that, we know we're going to take the risk, and we understand that. But ascent and entry, we have a pretty good understanding on how to do that, and we ought to, whatever we choose to do next, ought to reduce that risk. Next slide, please. Here's just a few more details about what we view a safer launch and entry system should have. The first one, abort escape capability from hatch closure through orbital insertion. A full envelope escape system free of black zones during nominal ascent trajectory. Third bullet is key for us, designed and built to meet NASA human rating requirements. There's an entire document that describes a lot of these things, but some of the elements are the structural factors of safety, crew situational awareness, manual control, robustness, redundancy, and things like that. I don't want to get into the details of that document, but the second sub-bullet there, not waived or rationalized away. One thing we get very concerned about is when we hear about systems and where they're discussing on how we're going to waive these requirements or why we don't need to meet these requirements because our system has X. We will weigh any new system as well as the current system in terms of human rating requirements and what we think the vehicle needs to have, and in the context of those requirements, and not how they're rationalized away. Last bullet, substantial test and verification. We view reliability derived from only modeling or analysis with skepticism until it's substantiated with test and verification. And everybody's heard the term paper rockets are always better, faster, safer, and cheaper. And I think until you get into the details of a design and really, really look at it and do an in-depth analysis of it, at least to start with, it's very difficult to say whether they can meet what they claim they can meet. Next slide, please. Just a few closing thoughts, and then you can ask me any questions you'd like. We believe strongly that we have to have a commitment. The budget must match the program. If we have a program that doesn't have an adequate budget, or the budget profile changes, that program's not going to be successful. I think we all know that, and we know how we got here today. But if we don't have the budget to execute the program, it's not a good program. If we commit to the program, however, we need to have the will to follow through. Like Mike Coates mentioned earlier, in our town hall, we talked a lot, how many more times are we going to change our program? How many more times are we going to start over? How many more times can we do that until before everyone loses confidence in our ability to develop and execute a program? There's always a better architecture or plan out there ready to replace the current one, and we're very concerned about that. We believe as an office that a change in architecture is going to delay IOC and it's going to increase costs. We also believe that it will trade one set of technical challenges for another. Quick word about gaps in access to space. We think there are two gaps that we need to be worried about. The first one is obviously the one that most people talk about. That's the access to space station after the space shuttle program ends, and the gap as we fly on Russian Soyuz to get to space station. But then the other gap to worry about, I think, is what happens between the end of the space station program and our next destination, whatever that ends up being. We think any new architecture or plan or change needs to really look carefully at both of those gaps within our likely budget and what we think we can sustain. And finally, we believe as an office we committed to both our nation and our international partners with the International Space Station program, and we think we need to honor that commitment and get our return on investment and do what we said we were going to do with space station. So that's a real brief kind of summary of where we are. I tried to talk in general terms. I didn't want to talk about specific systems. So at this point, I guess I could open up for any questions you might have for me.
Steve, thank you very much. Those were helpful comments, and I'm sure we've got questions. I've got a list of them myself. Wanda, do you want to start out?
If I may, sir, I'd like to start out. Thank you very much for your comments and for trying to get consensus across the group. One of the things that we've heard is that the NASA culture has become very risk averse, particularly after the 2003 CABE study. And at the same time, there's a clear message that I see in your charts that says we have to go beyond LEO, which is something that we haven't done before. Can you shed any light for us on how you balance those two objectives of being safer than we are today, or at least as safe as we are today? You said an order of magnitude would be desirable, and yet still be able to reach for things that we don't completely understand yet.
Yeah, certainly. That's it's a good question, and I've heard the comments about risk averse. Right now we're flying the shuttle, which is a 1 in 77 vehicle, approximately. You can debate. I think pure statistically it's like 1 in 64, but we can debate the numbers. What's that comparable to? Climbing Mount Everest is about 1 in 62, I think, somewhere around there. Believe it or not, a soldier on D-Day was about a 1 in 62 risk. So to give you an idea of the types of the magnitude of risks, there's a show on TV. I don't know if you've ever seen it. It's dangerous, most dangerous catch or something like that. It talks about the dangers of Alaskan fishing. The dangers of that job don't even compare to the dangers of this job. It's not even worth talking about it because they're so different. It's so much safer to go fishing in Alaska than it is to do what we do. So I don't think as an office we are risk averse. I don't think as an agency we are risk averse. When I look at it, and this is my opinion, every time we launch a shuttle mission, we are rolling the dice with the entire agency. We're probably one of the only government agencies, if not the only government agency, that lays it on the line every time we launch a mission. So I don't think we are risk averse. What I meant by the order of magnitude safer risk, I was referring to risk commensurate with our level of experience. If we have almost 50 years of experience getting in and out of low Earth orbit, it seems reasonable to me that the next vehicle we build ought to be able, and we believe it's achievable, ought to be a lot safer than the last time we flew, than the last vehicle we flew. Why do we build another vehicle getting in and out of low Earth orbit that has the same level of risk as the current vehicle? What I worry about is whether we can sustain another accident in the ascent and entry environment when we've already sustained so many accidents and we've lost a couple of crews doing it, whether we can continue to lose crews doing the same thing. Now recognize that the first flight of any new vehicle will have a lot more risk, and your true risk reduction that you achieve may not happen until the 9th or 10th flight or even further down the road. At least you won't know that. So we accept the risk with first flight. So I think the risk I'm referring to is a level of risk commensurate with our experience base. And we understand the risks and we take them every day.
Great. Leroy?
Follow up on that. Oh, okay.
Yeah. Let me get Leroy because I saw him, then we'll come back to you.
Thanks. Hey, Steve, thanks for coming out. What I know is a very busy schedule to talk to us. Kind of following up with Wanda, I also had a question about this risk averse because we've been hearing a lot from different people that the impression certainly is that NASA has become too risk averse, and you just said you don't feel that the astronaut office is, and I think I'd agree with you. Do you feel that the agency as a whole has become too risk averse? And as you know, CB, of course, is a pretty significant influence on the agency, and if so, what can CB do to try to help swing the pendulum back?
Honestly, literally, I don't believe that the agency is too risk averse. I mean, I've heard a lot of talk about it. We focused an awful lot on safety and risk post-Columbia, as I'm pretty sure we probably did post-Challenger as well, although I wasn't here during that time frame. And we spent a lot of time, we spent a lot of money. We worked really hard on shuttle. We revamped organizationally how we deal with dissenting opinion, how we run missions. The mission management process of a shuttle mission and an ISS mission is nothing like what it was 10 years ago. But as an agency, I don't believe we're risk averse. I believe, as I mentioned before, as a government agency, I think we take more risk than any other agency out there.
Jeff?
Yeah, I guess I've got two now. I want to, risk averse is one of those, I'm going to do a follow-up on the risk averse and then come back to another safety issue. The risk averse thing is, it's easy to throw that around as a qualitative term, we are or we aren't. But many times during the course of the fact-finding that we've been doing, I've pulled up a system that somebody's looked at and I've said, how come that's so much heavier per person or per pound of payload delivered than it was back in the Apollo days? And the answer I get is some variant of, we're just that much safer now. So it's hard to reconcile that statement with the statement that not in the astronaut office, not in the overall goals and objectives, but when you drive down to the decisions that are being made every day, it does seem like there's been a change in the weighting. And do you not see that, or am I just confused, or what?
Are you saying that something's heavier as in mass for safety?
Yeah.
Yeah, I guess I don't correlate mass with safety. I correlate design with safety, and so that's a difficult question. I don't know what the risk numbers with Apollo were getting in and out of low Earth orbit, for example, and that's what we're talking about.
Okay.
I know we were successful with every Apollo launch, but we also did.
It was close.
Yeah, it was. We probably took significant risk. You can argue in between Columbia or in between Challenger Columbia, I think we went 87 for 87 in launches. And if you take that statistic by itself, you say, wow, that's pretty good. And actually is pretty good. But I don't see that. We work real. I can tell you from my perspective, since we're riding the rockets, we work really hard on making sure those systems are as safe as possible, as does everybody else.
Well, let me come back to that, because that's the second question.
Okay.
It's easy to look at things like the CABE recommendations and it's hard to disagree with them. It's hard to disagree that what we do next should be a significant improvement over what we have done in terms of safety, in terms of the Earth to LEO piece. I'm quite concerned that because that is such an important value and has become such a flagship of what we want to do, that every possible agenda that of any possible point of view has been justified in terms of, well, you have to do it my way because it's safer. And there's a difference between saying we got to be a whole lot safer than we were, absolutely, and saying you have to pick my system instead of this system instead of that system because, on the 1,000th flight, when all other sources of failure have been eliminated and we are only talking about the probabilistic risks of the hardware, and there's no design issues, there's no infant mortality issues, there's no operational mistakes, everything is done with perfect workmanship. My system, this system is 20% different, on a number we know within a factor of 2 if we're lucky, than that number is. Do you see elements of this, or are you worried about this at all? Because these choices have consequences.
I'm not sure I quite. What are you asking me? Whether I'm worried about?
When I'm asking you, I'll make it more succinct.
Okay.
Stipulated that the new system has to be a whole lot safer than the old system. Should we then design the new system, with the only consideration being every safety parameter has to be turned to the highest possible number? Or if we just get a whole lot better, are we in the ballpark?
Absolutely not. We shouldn't design a system where every single thing is the only metric for success is the safety question. It has to accomplish the mission. In the end, a design is always a compromise between it. There's no point in designing a system that is absolutely safe that can't accomplish the mission. You have to be able to do the mission as well. What our office opinion is in the launch and entry area, we can do both. We have 50 years of experience, we can do both, and our design should address both. Is that going to answer the question?
Bo?
Steve, as a gentleman who is representing people who actually have to fly, and of course, safety has to be a very dominant concern. And my question to you is, I'd like to hear your opinion. If you believe that the smaller companies, like people who are engaged in COTS with NASA, are they capable developing a safe system for crew transportation to LEO?
Are they capable?
Yes.
First of all, I'm real excited about the COTS, and I would tell you that personally, I would like nothing better than to see the low Earth orbit mission turned over to commercial companies so that we could spend all of our bucks on going out and doing exploration. With regard to COTS, you know, right now we have COTS engaged, obviously, in resupply to space station, and I guess the way I would answer your question is, they're engaged with that. Matter of fact, we're depending on that after 2011 for space station to have the COTS folks show up and do that. And I want to see them succeed at that, and I think we should enable them to succeed at that. And once they've succeeded with that, then the next step may be a human-rated capsule or something like that with a human-rated rocket. When we get to that point, once they've demonstrated that they can do the cargo resupply, that's when I'd like to see that kick off. And then when that kicks off, we'll go ahead and weigh the design against the criteria I kind of set out in my slides. So I think, again, in the long term, I would like to see commercial entities take over low Earth orbit, and I think everybody would. And so I'm excited for that day to happen. I hope it does.
See, I'd like to call on Sally for a question and then to ask a question myself after that.
Okay.
I have one down here.
Oh, you do? Okay, fine.
Thanks. Steve, thank you for coming and sharing that perspective with us. You mentioned the gap between the retirement of shuttle and the coming on of the next system, and we're particularly concerned about the ability to support ISS during that gap. You also talked about some of the issues that you have even today with the shuttle system in meeting the mass constraints and meeting the volume constraints. And of course, those are exacerbated the moment the shuttle retires. And I wonder if you could just talk for a minute about the challenge that you see in supporting ISS after shuttle retires, even assuming good COTS capability relatively soon, and the support that's projected from the international partners.
Well, obviously, the space station was designed and built for shuttle support, and when you refer to space shuttle support, that means up mass and it means down mass. In the future, when the shuttle program ends, we're going to have an up mass challenge, which we hope to meet with our partners, the HTV from JAXA and the ATV from Europe, and continued progress vehicles, and hopefully COTS. Like I said, I hope that really succeeds, and that's how we're going to do it in the short term. The challenge, though, is how we operate space station without the down mass. So what that means to us, and we're actually looking at this in our office, and as I know the space station program in the agency is, how we operate space station and how we do the science and things like that on space station, our paradigm's going to have to change, and we're going to have to operate it in a different way. We're going to have to take more advantage of the facilities on orbit without the down mass to go with some of those facilities. And so I think that's probably the biggest challenge we're going to face in operations, maintaining supplies to keep the crews alive, obviously, and then as well as doing the science. So I think that's a big challenge we're working on now, and we have to continue working on. I guess the way I would equate this is I've been involved in flown a lot of different airplanes and watched airplane development over the years, and as well as the shuttle. The shuttle's role, since I've been in the office, has changed dramatically to what it was when I first got here. When I first got here, we were doing science missions. If you did an EVA or you had a robotic arm on your flight, it was a very rare event. Now, if you have a mission that has only 3 EVAs on it, we kind of look on it as kind of, well, that's not a real complex mission. Things have changed, but the role the shuttle has taken on has evolved. You look at an airplane like the B-52, which will be operational over 90 years when it completes its mission. it is not doing a mission now in any way, shape, or form envisioned that it would be doing when they built it back in the 1950s. I can list many, many aircraft and other things that are doing missions today that they never intended to do. What I would argue with you is the space station is a capability, and how we're going to use that in the future. It's hard to say. We couldn't envision it when we made it. We are where we are now, and we're going to go figure out a way to make that better. And make that work. I think whatever our next exploration program will be the same thing. We may design it for a specific place, the moon or an asteroid or something else, and we will no doubt end up using it in a different way in the future. And so the key to any architecture is the flexibility to be able to go after those additional goals.
All right. Okay.
Yeah. I hope I can be forgiven what you'll see is a far-out question. I'm fully sympathetic with your views that we should be as safe as possible with the things that we can do something about. But when you start thinking about exploration beyond LEO, there seems to be a long-term irreducible risk that you will run from exposure to galactic cosmic rays. And if you look at today's standards for current lifetime doses, it would seem to limit the ability for an astronaut who's never been in space beyond the Earth's magnetic field, limit their time in space to about 200 days. Do you believe that such a factor should limit our mission architecture and thus, in one way or another, influence the choices we make about launch and capsule infrastructure?
Well, I understand precisely what you're asking in terms of long-term exposure, because I deal with that today. In terms of the number of missions I can assign to nature, because we look at lifetime radiation exposure, and I in fact have some crew members that I can't refly because of that very reason on space station. Certainly going anywhere outside low Earth orbit, the radiation exposure is going to be greater, and I think that is a problem we have to go solve or we're not going anywhere. So I worry about that. There are ways to design to limit that exposure, and I think we need to go address that, and we need to come up with ways to limit the exposure. I don't think I could stand up here and say that I'm comfortable sending an astronaut on a mission that I know that will give them a fatal dose of radiation, if that's your question. I don't think we should be doing that.
I don't think the standards don't apply to fatal dose, but a lifetime, long-term increase in guess, morbidity.
Well,
it's not an immediate fatal dose in any case.
That's a fair question. In fact, I can be accused in one meeting with Life Sciences suggesting that can't we just because the way radiation doses work is it's calculated over your expected lifetime, and so one of my suggestions was, well, can we just ground rule out that astronauts only live to age 60, and then we can get a bigger dosage? But that wasn't too popular. But I think we need to go look at that and see. You know, like one of the things we're trying to do on Space Station now is we're trying to get some additional equipment, radiation equipment up there to measure different types of radiation so we can get a better handle on what we can really take. But this is a serious problem that we have to go solve or we're not going anywhere. So we've also talked about potentially having astronauts sign waivers in the future and things like that. So we're talking about all that. I don't think I can speak for my office and give you a good answer to that one. Depends on the individual. I mean, I've got crew members that will fly in anything, even one SRB with a shuttle. But quite frankly, it's my job to make sure that we don't put them in that situation.
Charlie, that's a good question. And if you have any follow-up you'd like to provide us in terms of the impact of particularly galactic cosmic radiation on architecture and the likes, that would be very helpful to us.
Okay, and so just so I understand, the question you're asking is, are we willing to go without the radiation protection?
Maybe, Mr. Chairman, if I may just jump in. The current limit, as we understand, is 3% exposure-induced death over lifetime.
Over the standard 20%, yeah, for a radiation worker.
Yeah, and so I don't want to interpret Charlie's question for Charlie, but I think your question was, whether the astronaut office would or would not be comfortable with a change in that level.
That's another way of looking at it, yeah.
And then I would just add as a separate note that our impression currently from briefings we've had is that it's going to be very difficult to do something physically that limits the galactic cosmic ray risk, certainly in deep space missions. But there may be biological remediation measures, and there's an awful lot of basic research that has to be done that could have important bearing on the problem.
Yeah, thank you. That's an important clarification. Thank you.
Yeah, and there's, we've taken specific steps on space station to minimize radiation for crew members that are up there for 6 months. I don't know if you're aware that we've actually have specifically designed sleep stations with mitigations in place to limit radiation exposure while on space station. And in terms of, there are some things you can do going interplanetary, and there are some things you can't do, and certainly the effect that has will be limited. So if you would go to the office and ask the individuals, it depends on who you ask, whether they'd be willing to accept a higher radiation dosage or not. I would suspect most probably would.
Steve, anything you could give us on that subject still would be helpful, particularly, as I say, coming back to the question, how it would impact missions, durations of missions, design.
Right. Okay.
I'd like to ask the last question, if my colleagues would permit that. My question pertains to the importance of going to the moon on the way to Mars. And you talked about concerned about public reaction and risk, and comment if we'd lost another shuttle, it probably would have been the end of the shuttle program. And if we were to go back to the moon and lose a spacecraft on the way to the moon or at the moon, the consequences for the human spaceflight program would probably be pretty severe. And I asked this question also in the context of ISS, which you'd indicated, Steve, that you thought it was important to continue to use it. Much of the science community has said that they don't see great science benefit from continuing the use of ISS. So one of the major benefits of continued ISS must be helping us get ready to go to Mars or wherever we decide to go. And so really the question in that context is, can you do things at ISS and not go to the moon? Is it important to go to the moon? Is ISS of any value to the astronauts if indeed it's not of value to the science community? And I overstated that, but for the point of the question.
I think both would be valuable. Let me address the moon first. And this is my opinion on this subject in that I think we need to go to the moon first to practice, much like Mike said earlier, before we go to Mars. I think learning how to operate on another planet, that's 4 days away, is something you ought to do before you try to do one that's 8 or 9 months away, because it can be very different. Space Station right now is a fantastic vehicle. It's primarily operated by the ground. Any vehicle we build to go interplanetary has to be autonomous in nature. Those are the lessons we need to learn. So, for example, with ISS, one of the things we could do with ISS that we ought to learn how to operate that spacecraft autonomously. Build it, and I've heard this suggested before, so it's certainly not my idea, but build a 20-minute delay into the communications of the ISS and go practice working autonomously. There are a number of things we can learn about ISS. Right now, we are learning extensive lessons on ISS for any type of future exploration. We are fixing systems that we never thought we could fix. We are learning right now with 6-person crew how we do provisioning, how a crew handles obviously long durations together, and all the issues that go with that. From an international perspective, we're learning an incredible amount. So we are already learning so much today for interplanetary that it's really hard for me to measure. But I could talk to you all day about the lessons we're already learning. I think there are many things we can look at in the future for ISS. There are potential to again, get this radiation thing, that question. We can answer a lot of that on ISS. I think that's important. So I think ISS can be utilized for long-duration preparation for long-duration missions. And I think the moon is an important place to go learn how to operate. We're only a short distance away. So I would support going to the moon prior to going to the Mars. One other comment I'd make about the moon, and I'm certainly no scientist, but I really wonder whether we understand the moon as well as we think we do. And I think there is some benefit to going there, because my personal opinion is we don't understand it as well as we think we do at this point.
Steve, thank you very much for your comments. We're appreciative.
Thank you.
It's now time to take a break for lunch. We're right on schedule. Could we meet back here? See, we'll take a 10-minute break and be back promptly in 35 minutes, so that's 12:35.